Hey guys, so classmate asked, what are left and right Riemann sums, and how do we solve them? To start off, let's understand what a Riemann sum actually is. A Riemann sum helps us to approximate the area under a curve. Just as we use integrals to help solve the exact area under a curve, a Riemann sum acts as an approximation to help us solve this same problem. Such approximations utilize rectangles, with the area of each helping us to get closer to the area under our curve. The more rectangles that are used, referred to as subdivisions or partitions, the closer our approximation gets to the right answer, as seen through the following graphs. These are foundational tools of integral calculus and are common problems found on the exam. Now, the difference between left and right Riemann sums has to do with how we choose to construct our rectangles. If we choose to make our rectangles touch the curve with its top left corner, then we are using a left Riemann sum. On the other hand, if we choose the top right corner, then we are using a right Riemann sum. Now, you may have noticed that for our rectangles, it looks like there is some area that the rectangles don't cover or go over. This is because our approximations are just that, approximations. So our estimations might be over or under, depending on the type of graph and what sum we are using. Note, if a function is strictly decreasing, then the left Riemann sum would be an overestimate, meaning that the rectangles will go over our curve and therefore be greater than the actual area. The right Riemann sum would be an underestimation, with the rectangles going under our curve and being less than the actual area. These conditions would be flipped if the function was strictly increasing. Then the left Riemann sum would be an underestimate and a right Riemann sum would be an overestimate. Although this entire time we've been talking about Riemann sums, we refer to visual representations of our graphs. Sometimes the questions won't actually have a graph related to them. However, the way we solve such questions still rely on the concepts stated before. Take, for example, this question. Approximate the area between the x-axis and y equals g of x, from x equals 10 to x equals 16, using a left Riemann sum with 3 equal subdivisions. Remember that Riemann sums are just approximations found through areas of rectangles that we can draw along a curve. So if we want to solve this problem of finding the area of a rectangle, we need two things, the width and the height of our rectangles. First, let's find the width of our rectangles, also known as subdivisions. The width of the entire area we are approximating is 16 minus 10, or 6. Using 3 subdivisions of rectangles, we know that the width of each rectangle has to be 6 divided by 3, or 2. From there, we need to find the height of each of our rectangles. Our first rectangle is in between the interval 10 and 12. Since we are using a left Riemann sum, then the top left vertex should be touching our curve where x equals 10, since it's the leftmost point. Therefore, the g of x value at 10 is our height, which is 5. We will repeat this process for the following intervals. From 12 to 14, the leftmost point is 12. So our second height is g of 12, or 1. From 14 to 16, the leftmost point is 14, with g of 14 being 7. If we multiply each respective height by our width of 2, we get the final area of 26 units squared. Now let's look at our problem using a right Riemann sum. Approximate the area between the x-axis and the graph of f from x equals 1 to x equals 10, using a right Riemann sum with 3 equal subdivisions. First, let's figure out the width of our subdivisions, or our rectangles. The width of the entire area we are approximating is 10 minus 1, or 9. Using 3 subdivisions of rectangles, we know that the width of each rectangle has to be 9 divided by 3, or 3. From there, we need to find the height of each rectangle. Our first rectangle is in between the interval 1 and 4. Since we are using a right Riemann sum, then the top right vertex should be touching our curve, where x equals 4, since it's the rightmost point. Therefore, the f of x value at 4 is our height, which is 8. We will repeat this process for the following intervals. From 4 to 7, the rightmost point is 7. So our second height is f of 7, or 3. From 7 to 10, the rightmost point is 10, with f of 10 being 5. If we multiply each respective height by our width of 3, we get the final area of 48 units squared. Note that for each question, I drew a makeshift graph about what the rectangles would look like if we separated them into their respective widths and heights to help us better visualize the question. The question can be solved without drawing out our graph, but understanding how we separate our rectangles from the given table can be helpful in solving the problem. I hope this video helped you to better understand left and right Riemann sums.